Good morning to all of you. I welcome you to this session of Programming in Python Lab. In today's lab, I'm going to discuss the concept of functions in Python. So we'll be discussing about the def keyword. Then we'll be discussing about the positional, keyword, and default arguments. We'll also discuss local and global variables in Python and how to use them. Then how the return statement can be used in a Python function. And if time permits, then maybe lambda function and recursive functions also, right? So obviously the first question that would come to mind is, what is a function? Like, you people have already worked with functions in C, C++. Function is, just like a program, okay, which makes your task easier. Like if you can divide all the problems in your say application that you're going to develop or some program that you're going to write, if you need to do multiple tasks, you can divide each and every task and store it under a different name, and that is known as a function. Okay, so you can create different modules of your problem, and then you can call them one by one as and when required. So this is the concept of functions, and it gives your problem a modular approach. It's easier to debug, right? And it's easier to use. Instead of a big long program, you can divide your program into modules, and you can call modules as and when required. And when we use functions in Python, we use the def keyword to declare the function. And as usual, the function has a name, has some arguments, can be without arguments also, and you need to refer to the name of the function and passing arguments to it while you need to call it. Okay, so I'll just shift to this Python IDE. If you are using some IDE, that's fine with me. So I'll just write a small function here, say def, and I can give the name as show. Right, this is a syntax. You write the keyword def here, then you write a function name. You should choose an appropriate function name, which by name you can judge that what this function would do. So we are taking a function show that would display something, right? And then I can write here, I can display, say, this message here. Okay, so this function is created. Okay, the show function has been created. How would you know? You can just write show here. It will tell you the function show at the memory reference that you see on screen. And if you need to call it, you can call it like this. And it would execute, and whatever content is there, it would be executed. So only we have written one statement here, that is print this message welcome, which is printed when we invoke this function. Right. So a function, as you see here, can be without arguments also. We can have a function with arguments also. Say, for example, I take this add function and I take two arguments here, right, A and B, and then I can use this return statement to return the sum of A and B. This is this add function. So while I'm calling this function, now this function add has got two arguments. So if I need to invoke it, I need to give both the arguments, right? So I can write something like they add 10, 20. So you'll see that it returns the sum of A and B, that is 30. Okay. When you call a function and pass arguments like these, then these arguments are known as positional arguments. That means the first argument goes to the first value goes to the first argument A, the second value goes to B. So 10 is passed to A and 20 is passed to B, right? So these are the positional arguments, right? When you call like this, this is positional way of doing it. You can also do call it like this also. You can write something like, say, B is equal to 19 and say A is equal to, right? So it will again return. Now you are referring to the arguments by their names. So you're saying that B is 19, so B is given the value as 19, and A is 13, so A is given the value as 13. So this style is known as the keyword argument. Now you are referring to the arguments to their names, so this style is known as the keyword argument, right? So let's use it in another way. I'll use it like this. Say I write here, say a is equal to 20, and then I pass here, say 10. Okay. So just see that this cannot happen. Okay. That means a positional argument cannot follow a keyword argument. Can you note this thing? A positional argument cannot follow a keyword argument, right? And I can then again call it like this. Say I can write here 10 comma b is equal to 30. Okay. This is perfectly valid. Okay. So what is not possible is that a positional argument, this is your position argument 10, okay, because this goes to the second position here B, but it should not be following a keyword argument. This is a keyword argument, right? So a positional argument cannot follow a keyword argument. Can you note this thing? Then there would be times like where you would require your arguments to have certain default values, right? Let's see the concept of default values here. So I can write here b is equal to 100. I can write something like this, right? So now in my function, there are two arguments, a and b. A would be given a value whenever you call this add function, and b can receive an argument, but if it is not passed anything, then it will take this default value of 100. So let's see the usage here. I can call this add function with just one argument. So this argument, this goes to a here, right? So it returns 200 because b picks up the default value of 100. So this is the concept of default values. So if I write like this, say b is equal to 100, okay? Say I write like this, okay? Okay. Just need to pass some value here. I'm sorry. Yeah. Okay. So now this is fine. Okay. Even though I've given the same value, even if I give a different value, when you provide a value, I'm providing the value to be through a keyword argument. So when I provide the value, the default value is overridden. Kindly remember this. Okay. The default value is overridden. Now, you've learned in C, C++ that your function can return only one value per call. That is, when you call your function, only one value can be returned. Okay. This is not the case in Python. In Python, a function can return any number of values, n number of values, right? Let's see how. Let's just revisit this function again here. Okay. Let me just make it a simple one. And then I can write something like this. Okay, I'm returning so many values. Okay, and if I call with values as 200 and 100, you can see that it returns 4 values. And it returns the value in the shape of a tuple. Okay, a structure that we will learn soon. This is a tuple. That is something that is enclosed in parentheses. This is a tuple. Okay. Right. So I think the first basic idea about functions, that is how to define the functions, what are the arguments, what are the positional, keyword and default arguments is clear to you. Okay. And next we will learn this concept of local and global variables. So what is a local and a global variable, right? So let's discuss this. A local and a global variable. For this, I'll write a short code for you. So we're going to discuss concept of a local and a global variable. So to begin with, you can understand this thing that any variable which is declared within a function, for that reason, even if it's the argument of the function, is local to that function. Okay, so if I declare a variable within a function, or if we are talking about the function arguments, then they are termed as local to that function. Anything outside a function is global. Okay, so let's write a small function here, say add, and then I can write here, say a comma b, right? Then I can write something like c is equal to a plus b. And then I can print the value of c outside this function. Okay, I try to print the value of C here. Okay, so just check this code first. I've taken a function with two arguments and I've used a local variable here, C. A and B are the arguments of this function, and C is a local variable which is having the addition of A and B. And I print C here and I print C outside the function also. Okay, so I'm not calling this function add as yet, right? So let's run this. Say I can give this name as f11. Okay, so you can see that this function is created here. Okay, and then after that this statement is executed. I'm trying to print the value of C, but C is not there. Okay, even if I write here, say C is equal to 100. Okay, you'll get the same response here, because this C that you have initialized here, you have calculated something here, is local to this function add, is active and alive within this function add, right? And if you try to access it outside the function, it will give you an error. Okay. Now, what I can do is I can show you that within the function C, within the function add, the C is accessible. How? We can call this function add here, say 100, 200. So obviously it will assign 100 to C, and then it will calculate this as 100 plus 200, that is 300. So for this part, when I call this add function, it will print 300, and again here it will give you an error. Kindly have a look here, right? So that part is okay. It will pick up 300, but then this will give you an error. So I hope that gives you an idea about the local scope of a variable. Now let's do something different here. Let's declare a variable C here as say 1000. Now this C, which is outside the function, is a global variable, and this C within the function is a local variable. Okay, so I'll just move this value from here. So let's see which is more powerful within a function. Like, let's see whether this C is printed as this calculated value or this value 1000. Okay, I'll just keep this as a comment, right? So again, we are looking for an output as 300. That means this C here is local, this C here is global, right? So if you want to access this value here in this function, okay, right? So you can write something like, you can use the global keyword. You can write here as global C, okay? And then you can assign C is equal to 100. So when you refer to this as global C, okay, then that means you are now using within this function add, you are using this global variable C. So if you assign the value of C as 100, okay, I'll make this as active, okay. And let's see now, even if I pass 100 and 200, it is going to print the value of C, okay, which is 1000 here. So we are using this value here, but then we change it here. We make it 100, okay. See the output now, right? So if you have changed this global variable's value within this function here using this global keyword. So when you write like this global C, that means now you are accessing or you're using the global variable C within this function. So if I don't assign it here, if I just leave it like this, okay, then let's see what's the value here. Okay, I hope it's clear now, right? So this C is not given any value here in this method or function add. It picks up this global value. So this global statement lets you, helps you to use a global variable within a local scope. Okay, so this is the concept of local and global variable. Let's now write a program to print the factorial of a number. So we'll write a function to print the factorial of a number, right? So we'll use this to print the factorial of a number. So I can define function as fact, okay, with an argument as n. So this function fact is going to calculate the factorial of n. It will return the factorial of n when it is invoked. For that, you can just initialize one variable. Then you can use a for loop here. Say for I in range. You know why I'm writing this. 1, n plus 1. It will go from 1 to n. Then you can write something like f is equal to f star I. That is how factorial is calculated. And here you can write return f. So this would be the function fact. Okay. And I'll store it in a function, say in a file named, say, factorial. Okay. I'll call it factorial. This is my py file, factorial.py. So this function has been created. In the current session, we have just created this. You can see here the file has been invoked in the shell as factorial.py. So if I use call this fact function without that also, it will calculate this, right? Fact of file, it is returning it as this value as 120. Okay. But if I close this session here, okay, and if I restart this, just close this also. I restart the shell here and I write here, say fact 4, nothing happens because I have not used that, imported that module. Okay. So what I can do here is I can write here import factorial. Okay. So this makes that function fact active, and then you can write here fact 4. But again, this will give you an error. You know it. You need to write the module name like this, factorial.fact, say 4. So it will give you 24, right? And you can also modify your import like this from factorial. You can write import fact. Okay. And then you can use this fact freely. Okay. Now, what is the benefit of writing this as a function? Let's say we need to calculate the binomial coefficient. You know, binomial coefficient, that is NCR. Okay. That is given by, that is what? Factorial of n divided by factorial of r into factorial of n minus r. This is what the binomial coefficient is calculated as, right? So if I use, say, 5c3, okay, this would be 5 factorial divided by 3 factorial and 2 factorial, right? So it would come to what? 10, I think, right? So let's write a program where we use this module factorial, okay, to calculate the binomial coefficient, right? NCR, that is known as. So I just write this to highlight this NCR. Okay. So what I can do is I can use this import from factorial, import fact. Okay. And then I can input the values of n and r like this. I can use the input statement with the eval function. So I can write something like enter the value of n, right? And copy this. I can just make some changes here, right? And then I can call this function. I can call like answer is equal to, I can write here fact n slash fact r star fact n minus r. That is how the binomial coefficient is calculated. And this fact n should be divided by the product as a whole. So we need the parenthesis here. And then you can write here the binomial coefficient is, right, and you can use the value here. Okay. So you see that in this particular program, calculating binomial coefficient, if I would have calculated the factorial of n, then the factorial of r, then factorial of n minus r. So I'm calculating the factorial thrice. I need to write all this code for this, and for this. But now I've written just one code here. I'll open the file here. That is the factorial file. See, I've used this code for this. How many lines? 3 lines. Okay. So if I write 3 lines for this, 3 for this, and 3 for this, there's a total of 9 lines. So with this, once you've written those 3 lines, just this one line can do the task here. So that is the strength of functions. So let's now run it. Say I can just give it a name as binomial coefficient. So if I run it and give this as 5 and this as 3, you'll get the binomial coefficient as 10. That is 5 factorial divided by the product of 3 factorial and 2 factorial. So this is how you can make use of functions to write some good programs, right? Okay. So I'll again start this Python ideally. Let's now write a program to print, to check whether a number is Armstrong or not. Okay. So to check whether a number is Armstrong or not. Right. So you understand an Armstrong number, we have already discussed it, that if the sum of the cubes of the digits of the number is equal to the number, then it's Armstrong. So I can just make a function here, say Armstrong, right? And then I can give an argument here, the number that I need to check. And you know what you need to do. You need to initialize a sum here, okay? And you need to store this number in some variable. And then you can use this variable, okay? So while k is greater than 0, you can write here, say d is equal to k modulus 10. Then you can write s is equal to s plus d cube, okay? And then you can write k is equal to k, the floor division, right? K is equal to k this. And when you have a conditional here that if your original number n is equal to s, okay, then you can print that your number is Armstrong, okay? Something like this you can write, or you can simply write here something like this. Okay. You know how to format things, so you can write else here. This will work, but I'll just put it like this, okay? And you can write here is not Armstrong. Okay, so we have used this function Armstrong. We have created this where we check whether n is Armstrong or not. So I take a sum as 0, use this variable k for my calculations. So keep n as it was, and this is how you calculate the sum of the cubes of the digit of the number. And if the sum that you've calculated is equal to your original number, the number is Armstrong. Otherwise, it is not Armstrong. So let's run this. Okay. You can give this name as Arm, right? And if I write here Armstrong, say 153, okay, so to tell you 153 is Armstrong. And if I take some other value, say this, it will tell you that whether it is Armstrong or not. So this way, you know, you can write any problem in the shape of functions. So that is always a good idea to use functions. So that's all for today's session. In today's session, we have learned about how to write functions in Python using the def keyword. We learned about the positional keyword and default arguments, and about local and global variables, and the return statement returning more than one value. And in my next session with you, I'll be discussing more on functions. Till then, keep watching my videos. Thank you very much.